to present my discussion about high diphthong pitch and intensity measurement using PRAAT program. Introduction. In the language system, speech is one of the most basic things to determine the occurrence of communication. Periodic sounds that are constant allow for the filtration of sounds that are then streamed through the articular consisting of teeth, lips, tongue, palate, and so on. That's what brings about an output or external sound. The external sound can be either vowels or consonant, and the tendency to communicate in speech is to produce the two types of sound in combination. This kind of externally can be used as a source of data in several studies related to phonetic and phonology. Speech analysis can be produced other outputs, especially in the field of technology. So, with research in the field of phonetics, there are several voice recognition programs such as voice control introduced by Apple or Google Voice used by Google, as well as some VR applied in automotive companies, such as voice command in rolling cars and DVSK for voice-based operation features. In the space system, there are several things that allow to be analyzed, such as the presence of different frequencies and features and pitch in each linear. In this case, native and non-native linear will have a pitch that is certainly different in saying the same word. But in measuring the amount of frequency or decibel issue by the linear, an accurate method of sampling and measuring data is required. Pitch height and intensity in speech are especially easy to measure with words that have double vowel or diphthong. And this is what was proposed in this study to measure the frequency and intensity of sound in the word chasing. Analysis in the form of contrastive analysis as an differences, deviation, or error in the word. The related software used in the study was PRAAT, a phonetic program for analyzing speech sound, although they were manipulative. The PRAAT application provides the feature to record sound directly using a device that has been installed, but is still a computer-based program, so it is not available for mobile. After getting the sound recording, PRAAT can then dissect the sound into a detailed spectrogram and produce its own, more detailed parts of the sound. A spectrogram consists of low and high frequency in the front of sound signal. It is also possible to measure pitch, intensity, and sound format truly and bring up graphs to illustrate the result. In this study, the analysis conducted only on double vowel or diphthong, which are common sound in English vocabulary and Indonesian. So, the tendency in speech error is resolved, especially for non-native learners with a background in Japanese culture, as term to teaching diphthong in vocabulary. Basically, diphthong itself is the glide sound of the vowel by switching position, represented by the average 12 points in one word. The limit on the number of diphthong used as data in the study was only 5 word vocabulary in English. The two pressure both set the same 5 words to see the difference and calculated the highest frequency and intensity obtained at the time the caller said the words. This can be a reference for non-native learners in saying words that are native-like, so that this possibility for experiencing sound errors and difference in meaning will be minimized. And discussion from the result of the analysis using the PRAAT program from both sources. The study showed a comparison of pitch and intensity different from both source persons. Both native and non-native respondents are female respondents with almost the same range of voices. The study used two English words spoken by both respondents by recording. Analysis research data. The analysis was conducted on the respondent's voice output in learning for two deep-heard words that had different frequency and intensity characteristics. Data result in the form for analysis in the amount of frequency and intensity of sound displayed in the form of table and graph. Broadly Speaking, the result of the analysis using PRAAT produced the following data details. Based on the table above, the detailed frequency amount in unit of hertz while with intensity unit decibel. The word used as data source are chair and here. In the table is also displayed transcription of word containing diptera so that you'll look how to read it. The column marked N shows the result data for native while NN means non-native. The numbers displayed on the table are a result of acquisition using PRAAT. Both respondents were women with different mother tongue background but had similar pitches and intonation. To get more accurate results, the study was conducted so that the difference can be seen with the repetition of number as a reference. B. Pitch and intensity for native linear. From the result of the study showed that the chasing of the word will give rise spectrogram and graphs that vary based on the diphtheron contained. Several studies have measured pole duration using PRAAT and produced the following spectrogram. And the spectrogram, the measurement made to the diphthong involved the format and also the duration of the vowels. In contrast to previous study, in this study, diphthong measurement focused more on pitch and intensity than diphthongal approved by learners native and non-native. Here are the results of pitch and intensity measurement on some diphthongs that have been done with the presentation of data in the form of graph and spectrogram. 1. Chair. In native linear, the word chair has a probability pitch of 210 Hz and an intensity 76.85 decibels. And for word here, in native linears, the word here has a pitch property of 189.2 Hz and intensity of 78.36 decibels. From the result of studies showed that the chasing of the word below gave rise to spectrogram and graph that vary based on the term contained in it. Data pitch and intensity of non-native linear is here. As in non-native linear, the chair has a property pitch of of 204.9 Hz and an intensity of 76.85 decibels. Is here. And number 2, word here in non-native linears, the word here has a property pitch to 214.9 Hz and an intensity of 80.52 decibels. The conclusion is, overall, the study of the frequency and intensity of sound showed a comparison of results presented through tables. From the analysis obtained showed a link between diphthong and high pitch and intensity in the enforcement of the word. It can be concluded that the learning diphtheria with the highest pitch value of both native and non-native linear is when respondents say the word with diphthong, which is the word chair, with a sound frequency of 204.9 Hz for native and 210 Hz for non-native learners. This is influenced by the less fall experience and increase in intonation. So, the pitch becomes high when saying the word. As for intensity, diphtheria in the word here has the largest intensity number of 78.36 decibel for native linear and 80.52 decibel for non-native linear. Based on sampling the voice data from the two pursuers, it can be concluded that diphthong has the highest frequency compared to the others, and diphthong has the highest intensity rate compared to the all diphthongs. All the graph and spectrogram featured in the study were obtained by processing sound data through extraction and processing of voice data using the PRAAT program. Each graph showed the frequency and intensity of the linear sound, while spectrogram show a variable data analysis and supporting elements, complete with pitch and intensity display on each spectrogram. So that's all. That's all from me, sir. Thank you for your consideration.